Use implicit differentiation and the product rule. So in this video, as it says, we're going to see how the product rule affects implicit differentiation. So let's take a look at our first example. So here we want to find the derivative of y to the fourth plus xy is equal to x cubed minus x plus 2. And hopefully we can see that we are going to need to use the product rule here, because we do have an x times a y. So when we differentiate this term, we are going to have to differentiate it using the product rule within what we know about implicit differentiation. Alright, so let's go ahead and let's just start taking the derivative of items. So the derivative of y to the fourth we know is going to be 4y cubed. But because we're taking the derivative of a term with a y in it, we need to multiply by dy dx, remember, chain rule. And then plus, and then we have the product rule. Now, product rule says we take the derivative of the first term, and our first term here is x. So the derivative of x is going to be 1, and then times the second term, which is y. Product rule says then we're going to add the first term, which is x, and then we're going to multiply by the derivative of the second term, and the second term is y, so the derivative of y is going to be 1. But remember, since we took the derivative of a y, we need to multiply by dy over dx. And if you notice, I put the product rule in parentheses. And this is a good habit to get into, because some of the functions we take the derivative of are going to have a subtraction in front of it. And we need to remember to distribute that subtraction too. So by getting into the habit of putting parentheses around the product rule will help us remember we need to distribute that negative. Alright, then we can keep taking the derivative of our right-hand side, and those are just all x values. So that's going to give us 3x squared minus 1, and the derivative of 2 is 0, so plus 0. Alright, so now we can do some simplification. So let's see, we're going to have 4y cubed dy dx, no change there. And then plus, and let's see, we can simplify. 1 times y is just going to be y, plus x times 1 is just going to be x, but then we have that dy dx on it as well. And then that's just going to equal 3x squared minus 1. Now, we don't necessarily need to do this step here, but to get in the habit of doing it, I'm going to take this plus sign and I'm going to distribute it. Because again, there will be times where we need to do this with a negative sign, where that will actually affect our signs. But anyways, that's going to leave us with 4y cubed times dy over dx plus y, and then plus x times dy dx, and that's just going to equal 3x squared minus 1. Alright, so with implicit differentiations, our steps were to take the derivative of both sides, boom, and then it was to get all the dy dx's on one side by themselves, which means I have to move this y. So we can subtract y from both sides. And that's going to leave us with 4y cubed times dy over dx, and then plus x times dy dx, and that is going to equal 3x squared minus 1 minus y. Alright, so now that all of the terms on the left-hand side of our equation have a dy dx in them, we can now factor out that common factor. So we're going to be left with dy over dx, and that's going to be times 4y cubed plus x, and that's going to equal 3x squared minus 1 minus y. And then we just want to get the dy dx by itself, so we can come in and we can divide both sides by the 4y cubed plus x, and we'll do that to both sides, canceling it out on the left, zoop, which means our final derivative, or dy over dx, is going to be equal to 3x squared minus 1, oops. Sorry, I got a little bit too excited. 3x squared minus 1 minus y, all over 4y cubed plus x. And boom, 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 done! Product rule inside of implicit differentiation. So nothing super difficult, but just a lot of things we need to pay attention to so we don't make those small, silly mistakes. Next up, we're going to find the derivative of x minus 2x to the fifth y to the fourth equals 1. And here again we can see that we are going to have to do another product rule because we have x to the fifth times x to the fourth. So we have product rule inside of our implicit differentiation. So let's dive in. Well, let's see, we can take the derivative of the x first, so that's just going to be 1. And then minus. Since we have a product rule here, again, we want to put that in parentheses to help avoid some distribution errors later on. But before I use the product rule here, I need to identify what my first and my second function are. Well, I'm going to put the 2 and the x to the fifth as my first function, and I'm going to let the y to the fourth be my second function. So, when I take the derivative of the first function, 2x to the fifth, that's going to be 10x to the fourth. Product rule says we leave the second function alone, so y to the fourth. And then product rule says plus the original first function, 2x to the fifth, times the derivative of the second function, which would be 4y cubed. However, we just took the derivative of a y expression, which means chain rule dy over dx. And then we'll close the parentheses that is equal to, and then the derivative of 1 is going to be 0. Alright, so now we can simplify the inside of those parentheses there. So this is going to give us 1 minus the quantity 10x to the fourth, y to the fourth, plus 2 times 4 is 8, x to the fifth, y cubed, dy, let's do that in red, dy over dx, and that is all going to equal 0. Now we need to take care of the negative. And again, we put the parentheses around the product rule so we can remind ourselves to take this negative and distribute it to both terms, not just the first term. And when we distribute this, we're going to get 1 minus 10x to the fourth, y to the fourth, minus 8x to the fifth, y to the third, times dy over dx, and that is going to equal 0. Alright, so now we have taken the derivative. Now all that's left is the algebra part of getting the dy dx by itself. So, our procedures say we move anything that doesn't have a dy dx to the other side. So I can come in here and I can subtract 1 from both sides. And I can add 10x to the fourth, y to the fourth to both sides. And those are going to cancel out on the left-hand side, leaving us with negative 8x to the fifth, y cubed, times dy over dx. And that is going to be equal to, and I just realized I made a mistake. I don't really know what my brain was thinking there, but for some reason, I decided to subtract x, and that is wrong. So again, there are tons of small mistakes you can make here. Try not to make them, or if you do, at least catch them. So, now that that mistake is fixed, my right-hand side is going to be negative 1 plus 10x to the fourth, y to the fourth. Now I want to get the dy dx by itself, so we'll divide both sides by negative 8x to the fifth, y cubed. And what we do to one side, we got to do to the other. On the left, the 8s and the x to the fifths and the y cubes will cancel out. That is going to leave us with dy over dx is equal to negative 1 plus 10x to the fourth, y to the fourth, all over negative 8x to the fifth, y cubed. And this is our derivative. However, students sometimes fall into this trap where they see, oh, there's a negative in the front and there's a negative in the bottom, so those will cancel out. And if you do that, you have been trapped. Because, remember, we can only cancel something out if it's a factor. And this negative belongs to terms. So if we really wanted to factor out that negative 1, we would have to factor it out of the numerator, so negative 1 times the quantity 1 minus 10x to the fourth, y to the fourth, and that would be all over negative 1 times 8x to the fifth, y cubed. Now they are factors. Now they can cancel out. So if we wanted to, we could also say the derivative is 1 minus 10x to the fourth, y to the fourth, all over 8x to the fifth, y cubed. And that would be our alternative answer, both of them correct, Both of them valid, good to go. Alright, and we have one final example. We're going to find the derivative of x cubed minus 5x to the fourth y squared equals negative 2. So, similar to before, we do see that we're going to have to use the product rule inside of implicit differentiation. But as we demonstrated in the past two examples, it's not that difficult, as long as we take our time and don't make the stupid copying mistakes that some teacher made on the previous slide. I wonder who that could have been. Anyways, the derivative of x cubed, that's taking the derivative of a variable, so that'll just be 3x squared. Minus. Then I want to put parentheses, because again, we want to remember to distribute that negative into both of the product rule terms. I'm going to set my first function to be 5x to the fourth, and my second function to be y squared. Product rule says take the derivative of the first function, which will be 20x cubed. Leave the second function alone, y squared. Then add the original first function, 5x to the fourth, and multiply by the derivative of the second function, 2y. But we just took the derivative of our function y, so therefore we need to add the dy dx, or technically multiply by the chain rule. And that's going to equal, well, the derivative of negative 2 is 0. Now let's simplify the inside of that product rule parentheses there, giving us 3x squared minus 20x cubed y squared plus 10x to the fourth y times dy over dx, and that is all equal to 0. Now we can take this pesky subtraction sign and distribute it into both of the terms. Again, that's why we used the parentheses there, to remind ourselves to do that. And that's going to leave us with 3x squared minus 20x cubed y squared plus 10x to the fourth y times dy dx, and that is going to equal 0. And then similar to the last problem, our goal is to get the dy dx by itself. So step 1, move everything that doesn't have a dy dx to the other side. So I'm going to subtract 3x squared from both sides. Zoop, gone. Then I will add 20x cubed y squared to both sides. And that's going to zoop cancel out on the left, leaving us with 10x to the fourth y times dy over dx is equal to negative 3x squared plus 20x cubed y squared. And we are almost finished, because now we just need to divide both sides by 10x to the fourth y, and we will have the dy dx by itself. Woo! So here we have it, dy over dx is going to be equal to negative 3x squared plus 20x cubed y squared all over 10x to the fourth y. And now you might be telling yourself, wait a second, if this is the answer, why hasn't he put it in a box yet? Because I might have lied about it being the answer, because Newton is going to be super picky. They're going to ask you to simplify this down completely. And sadly, this is not simplified down completely, because every term has an x in it, which means we can factor an x from the numerator, factor an x from the denominator, cancel it out, and then simplify. So let's do that. Thank you, Newton. So this is going to be x times the quantity, negative 3x plus 20x squared y squared, and that's all over x times 10x cubed y. Now, since we have an x factor in the numerator and an x factor in the denominator, those can cancel out, leaving us with our simplified answer of negative 3x plus 20x squared y squared all over 10x cubed y. And that is our final simplified derivative that Newton will accept. And that is it, folks, using implicit differentiation and the power rule.